Okay, so let us wait for 2 minutes and then we will start. So let us start. First question. Find inverse Laplace transform of 1 upon s plus 2 for s greater than minus 2. Okay. So from the previous class, we can say that its inverse Laplace transform will be, or we can write it like this: 1 upon s plus 2 is equal to e to the power minus 2t qt. Why? Because it is the ROC is greater than minus 2, right? Okay. Let us write here as ROC is greater than minus 2. Okay. Then come to the next problem, question 2. Find inverse Laplace transform of, again the same problem, but ROC is different. 1 upon s plus 2 for s less than minus 2. Okay, so here we will get Laplace inverse Laplace of 1 upon s plus 2 is equal to e to the power minus 2t. It will be minus e to the power minus 2t u of minus t. Why this is coming? We have discussed in previous session. Depending upon the ROC, the Laplace transform may change. As ROC is s less than minus 2. Fine. Now come to the third problem. And it is very interesting problem. Find inverse Laplace transform of xs, capital Xs is equal to 2s plus 4 upon s square plus 4s plus 3. If there are three conditions. Question A is greater than minus 1. Problem B is less than minus 3. Problem C minus 1 less than less than is less than minus 3. Right. So these are the three part of this question. So you people may take 1 minute and try to understand the question. If there is any query, you can ask. First, understand the question. What is inside it? What is asked? To understand, you people take 1 or 2 minutes and try to understand what is the problem. Okay, so let us start. The question is find inverse Laplace transform of x is equal to 2s plus 4 upon s square plus 4s plus 3. If there are three conditions, s greater than minus 1, s less than minus 3, minus 1 greater less than s less than minus 3. Two s plus 4 s square plus 4s plus 3. Let us break this. This is two common, s plus 2, and we can break it into factor, right? One is s plus 3 and another is s plus 1. S plus 1. Okay. And the upper portion, can we write okay, let us take as it is. It was 2s plus 4. So can we write it as s plus 3 plus s plus 1 divided by s plus 3 multiplied with s plus 1 is equal to 1 upon s plus 1 plus 1 upon s plus 3. Okay. Now let us look at this. Let us make it minus 1 and this is minus 3. So the first problem is s greater than minus 1. For s greater than minus 1, xt will be x greater than minus 1 means x greater than minus 3 also include this, right? That means if for this also it is similar type. So it will be e to the power minus t plus e to the power minus 3t ut. Okay, so for s less than minus 3, is less than minus 3, xt will be minus e to the power minus t plus e to the power minus 3t u of minus t. And question C, for minus 3 less than s less than minus 4. That means ROC is this region, right? So xt will be s is greater than minus 3, so it will be e to the power minus 3t minus 3t ut minus e to the power minus t u of minus t. Okay, so please look into the answer, then we will move for the next problem. तो दूसरे से पूछे कि क्या हाल है तभी तक कैसे सब ठीक हो रहा हूँ शुरू कर दिया और इसलिए बाहर इंस्ट्रूमेंट के साथ में ठीक है तो तेरे पे बोलोगी Okay, so let us move to the next problem. Question 4. Find Laplace transform of this. This is the function gt, and we have to find the Laplace transform of gt. Okay. So now look here. How can we define the gt? Can we define it using step function? Yes, we can do that. So gt, can we tell u t minus 3 minus u t minus 5? So gt is equal to, from this figure we are getting u t minus 3 minus u t minus 5. Fine. So its Laplace transform, capital GS, will be e to the power minus 3t minus 3s, because ut's Laplace transform is 1, right? So it will be e to the power minus 3s minus e to the power minus 5s. Into 1 upon s. Why? Because ut's Laplace transform is 1 upon s. So we can write e to the power minus 3s upon s multiplied with 1 minus e to the power minus 2s. Fine. So look at the solution for 1-2 minutes, and then we will move for the next problem. You people take 1 or 2 minutes to understand what we have done. Then we will proceed for the next problem. Next problem is very interesting. First, you want try to understand what we have done in question 4. If there is any query, you can ask. Otherwise, we'll move for the next problem. You take 1 more minute and look into the solution. Okay, so next problem is Find inverse Laplace transform of x is equal to s plus 5 divided by s plus 1 multiplied with s plus 3. S plus 3. This is very interesting. We will break it into two parts. So please, you people try to think how we can break it into two parts so that our problem becomes easy. Think about this, and if anyone can, please tell. How can we break this excess? You people take 2-3 minutes and try to think. How can we break this into different parts? This is very interesting problem. Okay, so let us try to solve. Can we write xs is equal to half multiplied with s plus 1 plus s plus 3 divided by s plus 1 multiplied with s plus 3 plus 1/2 multiplied with s plus 3 minus s plus 1 divided by s plus 3 multiplied with s plus 1. Now, can we write it as half of 1/s plus 3 plus 1/s plus 1 plus half multiplied with 1/s plus 1 minus 1/s plus 3. Now it is easy to calculate the inverse Laplace transform, right? Now please try to solve and then take 1-2 minutes and try to solve and try to understand what we have done in this line. There is a jump right from here to here. So please try to understand what we have done, and if there is any query you can ask. Take 2-3 minutes. You people try to understand what we have done here. One more minute you take, then we will proceed further. If there is any query, you can ask. Okay. So, can we write xt is equal to half of e to the power minus 3t plus e to the power minus t plus half of e to the power minus t minus e to the power minus 3t. Can we write it like this? Yes, we can, right? If we write it, okay. Finally, we will get 2 into e to the power minus t minus e to the power minus 3t. You people do the calculation and rest, okay? Then question 6. Given two continuous time signal, given xt is equal to e to the power minus t and yt is equal to e to the power minus 2t. Okay, which exists for t greater than 0. For t greater than 0. Fine. Find the convolution zt. Find the convolution zt is equal to xt convolution yt. Sorry. So please look at the question again for 2 minutes and try to think how we can solve this. Then we will proceed further with the solution. You people take 1 or 2 minutes to understand the question and try to think how we can solve this in which way. Anything you can remember from the previous session, what we have discussed in the previous session regarding the convolution. You will take 1 more minute and try to understand what we have done and in which way we can proceed. Okay, let us try to solve. Given that xt is equal to e to the power minus t, so its Laplace transform capital X will be 1 upon s plus 1. And yt is e to the power minus 2t. So ys is equal to 1 upon s plus 2. Okay. Now come to the main point that we know that convolution in time series, time domain signal is equal to multiplication in frequency domain signal, right? So if we want to calculate xt convolution yt, we first calculate xs multiplied ys, and then we will calculate inverse transfer function, inverse Laplace transform. Okay. So Jds is equal to xs into ys is equal to 1 upon s plus 1 multiplied with s plus 2. Hope this is clear till now for everyone. So now we write it like this: s plus 2 minus s plus 1 divided by s plus 1 multiplied with s plus 2 is equal to 1 upon s plus 1 minus 1 upon s plus 2. So zt will be in inverse Laplace transform of zs, right? So it will be e to the power minus t minus e to the power minus 2t multiplied with ut. Fine. So look at the answer. Try 2-3 minutes to digest the answer. Okay. Then we'll proceed further. Take 1 or 2 minutes more to understand what we have done till now. Then we'll proceed for the next very interesting problem. Let us move to the next problem. Question 7. If there is no query, then we will proceed further. If there is any query, you can ask. Consider in a LTI system with with impulse response HT is equal to e to the power minus 5t ut. ut. If the output is yt is equal to e to the power minus 3t minus e to the power minus 5t ut. Then the input, find the input xt. Find the input xt. So this is the problem. Please try to understand what is in the problem, what is asked in the problem. You will take 1 or 2 minutes and try to understand. Then we will proceed for the solution. Okay. If there is any query regarding the question, you may ask. If it will take 1 or 2 minutes. If we will try to understand what is asked in the question. Understanding the question is very important, right? It may look a little bit difficult, but it is not. It will take 1 minute more. Okay, so let us come to the solution. Impulse response. HT is given. E to the power minus 5t ut. So Hs will be one upon S plus 5. Okay. Output is given. Yt is the output. E to the power minus 3t minus e to the power minus 5t ut. So Ys will be 1 upon S plus 3 minus 1 upon S plus 5. Okay. So we know that output Ys is Hs multiplied with Xs for linear time invariant system. So Xs is equal to Ys upon Hs is equal to 1 upon S plus 3 minus 1 upon S plus 5 upon 1 upon S plus 5 is equal to it will be S plus 5 divided by S plus 3 minus 1. So if we take the inverse Laplace transform, so let us more simplify this to take the inverse Laplace before taking. This will be S plus 3 and S plus 5 minus S plus 3. is equal to 2 divided by s plus 3. So input the question was to find the input xt is equal to 2 multiplied with e to the power minus 3t ut. Right? So if we can try to understand what we have done here, take 1 or 2 minutes, then we'll proceed to the next program. Next program is very simple. Please try to understand what we have done. Okay, so let us move to the next problem, question 8. It is very important and interesting problem. Given xt convolution xt is t e to the power minus 2t ut. Find xt. So given that xt convolution xt is equal to t e to the power minus 2t ut. So taking Laplace transform at both sides, xs here whole square, because it will be xs multiplied with xs, right, is equal to its Laplace transform will be 1 upon s plus 2 whole square. Using the properties of Laplace transform, you can find it easily. So xs is equal to 1 upon s plus 2. So small xt is equal to e to the power minus 2t ut. Fine. Look at this question and try to understand what we have done here. Then we will move for the next problem. Please try to understand what we have done here. If there is any query, please ask. Okay. If there is no query, then we will proceed further. Question is the impulse response of a linear system. Given impulse response of a linear system e to the power minus 2t ut to produce a response of t e to the power 2t e to the power minus 2t ut. What will be input? Okay. So this is the problem and we need to find the solution. First thing we need to understand that what is given here. Impulse response is given and it is ht is equal to e to the power minus 2t ut. This is given. So its Laplace transform, we can write hs is equal to 1 upon s plus 2. Fine. And what else is given? Output is given, right? Look, try to understand. Look at the question, the part of the solution what I have written, and try to understand it. Up to this, is it clear? Up to this, if there is any doubt, you can ask. Take 1 minute and try to understand. Okay. Sorry, yt output is given. Yt is equal to t e to the power minus 2t ut. So y of s is equal to 1 plus s plus 2 whole square. Right? Now, what is xs? Input. Laplace transform of the input. Xs is ys upon hs. Is 1 upon s plus 2 whole square divided by 1 upon s plus 2 is equal to 1 upon s plus 2 So input xt is e to the power minus 2t ut. Okay, take 1 or 2 minutes and try to understand what we have done. Then we will proceed further. Okay. Take 1 or 2 minutes and try to understand what we have done. Take 1 more minute and try to understand. Then we'll proceed for the next problem. If there is any query, you can ask. Next problem, question 10. Assuming zero initial condition. Initial condition is zero. Okay. If initial condition is zero, the response yt of the given system response yt of given signal, given system with input ut is dash, and given system is this. This is 1 upon s. This is us. This is ys. Right? So us, let us come. So us is Laplace transform of ut. That is 1 upon s. So y of s is equal to 1 upon s multiplied with 1 upon s is equal to 1 upon s square. So yt is t ut, inverse Laplace of ys, right? Take 1 or 2 minutes and try to understand what we have done here. Then we'll proceed with the next problem. Sorry. Take 1 more minute and try to understand what we have done here. Okay, so let us move to the next problem, and it is very interesting problem. Question 11. A continuous time LTI system is described by is described by d2yt d2t d2 plus 4 dyt dt plus 3yt is equal to 2 dxt dt plus 4 xt. Fine. Assume zero initial condition. Assume zero initial condition. Xt is given xt is e to the power minus 2t ut. Find the response yt. Okay, so you people take 2-3 minutes and try to understand what is the problem here. Okay, then we will proceed further with the solution. Try to think in which way we can get the solution. 2-3 minutes you people take. You people try to understand the question. If there is any query, you can ask. Okay, so what is given here? Given d2 yt dt2 plus 4 dyt dt plus 3 yt. This is left hand side, right? And right hand side is 2 dxt dt plus 4 of xt. Taking Laplace transform in both sides. So we can get it like s square. Okay, initial condition is 0, so it will be s square ys plus 4 s ys plus 3 ys is equal to 2 s xs plus 4 xs. Fine. So if we take ys as common, then we can write s square plus 4s plus 3 multiplied with ys is equal to 2s plus 4 multiplied with xs. Or ys is equal to 2s plus 4 divided by s square plus 4s plus 3 multiplied with xs. Okay. Now what we already have, xt is given. Okay. So xt is e to the power minus 2t ut. So xs will be 1 upon s plus 2. And what we need to find out? We need to find out yt, right? So now ys is equal to 2s plus 4 s square plus 4s plus 3 multiplied with 1 upon s plus 2. So it will be 2 upon s square plus 4s plus 3 is equal to 2 s plus 3 s plus 1 is equal to s plus 3 minus s plus 1 divided by s plus 3 multiplied with s plus 1 is equal to 1 upon s plus 1 minus 1 upon s plus 3. So the output yt is e to the power minus t minus e to the power minus 3t ut. Okay, so is it clear till now? Please take 1 or 2 minutes and try to understand what we have done in these steps. Then we'll proceed for the next rule. Take 2 minutes. Okay, so let us move to the next rule. Question 12. We have very limited time, so this will be our last problem, probably. The system is described by D2 y dt2 plus 3 dy dt plus 2 of yt is equal to xt. Okay. Initial condition 0 given zero and input xt is 2 ut. Find yt. Okay, so given d2y dt2 plus 3 dt dy dt plus 2 yt is equal to xt. Taking Laplace transform with both sides, it will be s square y of s plus 3s y of s plus 2 y of s is equal to xs. So we will get s square plus 3s plus 2 y of s is equal to x of s. Yt is equal to 1 upon s square plus 3s plus 2 multiplied with xs. Now xt is equal to 2 of it. So x will be 2 upon s. Now ys is equal to 2s square plus 3s plus 2 is equal to 2s plus 2 multiplied with s plus 1. Right? And this can be written as 2 upon s minus 2 upon s plus 1 and this will be 1 upon s plus 2 1 upon s plus 2. So it is 1 minus 2 e to the power minus t plus e to the power minus 2t with t. Okay, so let us conclude today here. We'll start again next session. Underwater tracking is irrigation with no option noise.